Anatoly, welcome to Validated.
Hey, great. Good to be here.
This is a show that you started that I took over that now you're a guest on.
What happened to the No Sharding podcast?
It seemed too adversarial. This has been a long time coming. We chat a lot, which is great. We do Twitter Spaces fairly regularly. We got Breakpoint coming up, but I thought it'd be nice to sit down and kind of just slow things down a bit, have a bit of a longer conversation about some of your thoughts and experiences in the last year about getting the network to the state that it is now, and sort of where we've got probably line of sight to a bit more stability. Like, what are some of the big ideas that you're thinking about for the next year or two of development on the Solana network?
Awesome. Yeah, where should we start?
So I guess I want to start going back a little bit to, let's call it like the early like Q1 of 2022. And this was probably in a period where, we'd had that first major outage since people started using the network in September of 21. And there was just suddenly it felt like the network was congested every day. I'm kind of curious, less on the, we'll get into the technicals of what some of the solutions were, but as someone who was one of the original 4 people who really conceived of this network and sort of started building it, what was that process like for you of sort of seeing ideas that you guys had thought might work or systems you thought you designed well enough, fall over in production? That's not usually a conversation you get to have with founders.
This was actually a spot of the design that we left almost intentionally not well defined. We had a solution that we thought would work sufficiently well, and it did for a bit, and then it fell over. And I think it was really important to kind of, I think if you try to solve all the problems all at once, you end up with something that either doesn't work or takes so long to build or is very extremely conservative. And the latter part is what a lot of layer ones end up with at launch. They kind of build something that is robust but very conservative. And that means that once the system's up and running, it becomes really, really hard to make the kind of changes that are necessary to move it to that next level of performance. And these are kind of really hard trade-offs to make, because you really want to ship a good product. You want it to be fast, you want it to be cheap, and you want it to be stable. And picking over optimizing on the last one early on will kind of box you in design wise. We really needed to see what fails and how it fails. And obviously you don't, if we knew that these were failures that could cause an outage, the interesting part was that the things that cause an outage wasn't the load itself. It was problems in the code base that couldn't handle the load at that specific performance. They basically blew up in memory. And that memory failure is what caused the validator to fail. It wasn't the load itself. And at one point, we fixed a bunch of these issues and the network was more or less stable. It would get congested and kind of block production would slow down. But consensus wasn't falling over. You still would land transactions, but you get kind of really these really annoyingly, you have to retry a bunch. If you're a DeFi protocol, you get failures and stuff, these kind of UX problems that make it a very unpleasant experience. So that reliability part, that last part, is what needed an actual good solution that was robust all the way through and through.
Yeah, I want to go back to something you said, which was that there's a trade-off there that had to be made in the early days between doing something new and doing something conservative. And it seems to me like that was a trade-off that a lot of founders were making 20 years ago. And it seems like it is like this is not a Web3 thing, but this is sort of fallen off the spectrum that you're allowed to launch a V0 product or a V1 product, and it's allowed to occasionally fall over to push the bounds of like what's possible. And there seems to be a lot of like
It's not that you're
founder
allowed or not.
shaming.
No,
What?
I think the thing is that like people pretend that they launched the product that is not a V0 product, but all of them are V0 products because that they literally just went to production, and it takes multiple years to figure out in a complex system. Like if it took 2 years to build, it's going to take at least 2 years to stabilize. So that's kind of like how long it took for Solana. Like it's just no matter what, and anything that complex, it needs time in the hot seat, so to speak, to like kind of stress test it from every possible angle.
How did you get comfortable with that? Because I think today most founders are still not comfortable with that idea.
It's not you don't have the option. Like
Well, you can lie.
Yeah, but like I mean, every engineer that's had like the experience of working on big systems that they had to bring up from 0 to 1 that took multiple years to build knows this exactly. Like things go wrong and it takes a long time to stabilize something. This is why you want to really optimize for shipping small changes as fast as possible that are incremental and that really, that you can kind of roll out one feature at a time and test things out. But with when you're building like a new database or a new operating system or a new blockchain, you have to solve multiple hard engineering problems at the same time. And if you don't innovate on them, the problem that you don't innovate on ends up being kind of your Achilles heel that becomes too slow or too expensive or whatever. So that kind of prevents you from going to, like to that next generation of technology. So this is kind of, I think, why a lot of other layer ones that, in my view, kind of take this with a grain of salt, but folks that, copied EVM or just like modified one part of the Ethereum stack, you just really can't it's not going to be a next generation blockchain because you only fixed one problem. But Amdahl's law means that if you have 7 other hard problems, that fixing that one problem is only going to give you like marginal benefit, like 5% improvement overall. You have to fix all of them. Fixing all of them, there's a 50-50 chance that you get it right, like you don't ship a bug. So if you have 8 hard problems, each one of them has a 50% chance of having a bug. The probability of you not having any bugs is 1 in like 256, just virtually 0. So you kind of know coming into this that like, okay, there's going to be some bugs and some of them are going to be hard to fix and problematic, but that's just part of like, you just have to get through it. I think we got pretty lucky that the bugs were just stressed, like heavy load issues. That's actually, I think we got pretty lucky there.
So Solana has made a few design decisions that sometimes are criticized and other times are held up as the reason it can be as performant as it is today. Can you walk us through a little bit of why those decisions were made sort of at the very base layer? I'm thinking of sort of like the way Solana Virtual Machine is thinner, if that's the right terminology, than many other blockchains between the VM and consensus layer.
Yeah, a lot of this design came from trying to figure out what problem are we solving? Like what are these technologies good at? And I thought that, there was already a narrative that Ethereum is working on settlement and Bitcoin is like store of value. And none of those problems were just like interesting to me. Not that they're not important, right? It's just not something that I like got excited about. What I thought was cool was the idea that you can use this like same Byzantine fault tolerant systems to give you guarantees that information is synchronized around the world in a fair way and as fast as possible. And like providing those guarantees that everyone has an opportunity to submit data and everyone has an opportunity to read it kind of at the same time simultaneously around the world. And then making that system be as fast as possible as physics allow. That's the engineering challenge. And the benefit of having like fair, open kind of like information engine is that it's a really, really good spot for finance, for lots of stuff, for like financial rails and trading and all these other things. It solves a lot of problems that centralized systems do. So my thought wasn't that we're building a competing settlement layer to Ethereum or a competing store of value to Bitcoin. It was that if we get this right and there is this open platform for synchronizing state around the world at the speed of light, that's competitive with very, very important businesses like CME, NYSE, all of trading, all of finance can run on this. And it's not going to displace them. It hopefully becomes the infrastructure layer that glues them all together. And they all know that they're getting a fair, that no one is like, clobbering them on rights. No one is getting ahead of them unfairly on rights or withholding data and getting like a bit of an information edge ahead of them. All those things are great, like a good for those. So this is what solving that problem and kind of keeping that in mind, that we need to make the system synchronize data as fast as possible and allows data to be submitted as fast as possible. Those two problems were just always in my mind. So this is where the design comes from. It's just trying to always like solve those problems. So in that context, like why a lot of folks argue on crypto Twitter is that if you have this system that can synchronize information and guarantee that it's globally synchronized, it has feature overlap with things like settlement and store of value. Just simply because once you solve this, fair information symmetry, whatever you want to call it, you solve that problem, you also have to, by definition, implement something that does settlement of state or could be a store of value because it's the token that runs on this thing, like prevent spam in the system. What makes it a store of value? It's a meme, right? But but it exists, right? And people could use it as a store of value, like if they wanted to. So there's overlap there between what we're building and the features that Ethereum and Bitcoin provides. But we are solving a specific problem. Everything kind of flows from that. So design-wise, like for that system to exist and for it to handle more bandwidth, that bandwidth is only going to come from parallelizing how information flows. And that means how it flows through the smart contracts or through the propagates around the world and stuff like that. So all the design decisions kind of came from that.
Yeah, it's kind of interesting to think about what analogies do and don't exist in the rest of software. Like most global systems are not synchronous, and most synchronous systems are not global.
But Google Spanner, like there are systems like that. People have built them because they solve a large class of problems for a lot of applications that developers then don't have to like go build, re-implement a whole bunch of algorithms. So that there's like, once you build it, like it's a very, very powerful tool.
Right. And maybe I'm curious if you'd agree with this or not, but it feels like most global synchronous systems are actually not particularly concerned about how quickly they synchronize information. Like, yes, the YouTube video you uploaded needs to be in every YouTube data center, but it doesn't, like, the speed in which it arrives in every data center is not like the defining factor of whether YouTube is successful. So I'm kind of curious what class of problems really need both of those two things, like very fast propagation of the synchronicity, for lack of a better term, as well as also a global state.
Like data structures that are like shared between a bunch of users. You can actually look at like even things like that are as simple as a news feed on a Facebook or like a shared file system like Dropbox, stuff like that. You really start getting into like weird UX problems that if they're not synchronized within some time guarantee, you get like your 0.1% of users get these weird bugs and they'll start complaining. And 0.1% may seem small to people, but it's very large number to DevOps engineers. If you have 1 million users, 0.1% is like, was that 10,000 complaints that
A lot of
day?
people.
That's bad. You all of a sudden get 10,000 tickets. That's a very bad day. That's a bug that you need to fix. So like that's 1 million users is not even like that big of a size. It's pretty big, right? It's a product with very strong PMF. And when you scale it to 100 million to 1 billion, like things like Facebook and Google, you start really, really caring about places wherever these inconsistency failures will bug or annoy users.
So kind of looking at that work that's been done sort of since that like Q1 of 2022, there's a huge amount that has happened since then. It feels like just in the last 6 months, like something has changed, and I'm sure it's actually 100 things that have all slowly been changed, and that it adds up to the cumulative experience we have. But you saw 1.16 be released and hit majority adoption on mainnet beta, and the response from the community was like, wow, something's new here, something's different. Like, what was that 2 years, year and a half of engineering work to make that moment happen?
It is a lot of optimizations. Like when we only had 20 people to build Solana, and like only like 12 of them, including me, were engineers. So when we launched, we wrote the code as well as we could have, but it's obviously not going to be as efficient as 40 engineers that are optimizing it for 20 years. And in the 2 years since, or like how long has it been? 1.5 years or 2 years since launch? 3 years.
March of 2020.
Yeah. It's been 3 years since launch. We've had the blessing of being able to see what works, what doesn't in production, and be able to optimize a lot of the code paths. And I think this last release, the accounts index that is synced to disk, I had the prototype that I handed to Jeff Washington 2 years ago, I think at this point, where I wrote like a prototype implementation of this index, and I benchmarked it, and it was going to disk. And I showed him, hey, look, if we do this, we can save like a bunch of memory. And it literally took him 2 years to land it into a mainnet release where it's on by default. Because these problems are hard, right? When you're building something like this, you get a lot of like, if there's some bug in the implementation, it'll chew through the disk, or it'll open too many files, and like a whole bunch of other like these weird problems come up when you start trading off these resources between RAM, which is very easy to use but expensive and limited, to disks, which are somewhat slower but much cheaper, and therefore plentiful in space, but also have trade-offs like they wear out. Like RAM doesn't wear out, so you have to balance all of these weird physical limitations of the hardware that runs digital systems and math, which is supposed to be limitless. When you map it to hardware, which has limits that are physical, like based on physics and manufacturing limits, you start getting into all of these edge cases, which is where why systems engineers are going to be employed, and making sure that AGI systems don't fall over for millennia.
Do you find that empowering or annoying? Like when the math runs into the real world, and not the real world in the sense of like, oh, there's a bug in the code, but like, oh, fundamentally, like computers are still physical things in the real world at some level.
Yeah, they overheat.
Yeah.
I think those are really cool, fun problems, because it's like if you've ever played resource management games where you have like, and you're like building a civilization or whatever, and you gotta balance all of these things. Those are fun optimization problems. You're trying to schedule a bunch of work and then make sure that you don't overuse one resource or another, and like you're optimally distributing the work and stuff like that, and load between all of these different things. And those are fun. My job at Qualcomm was managing that on a much smaller scale on a single chip, I was balancing between the DSP and the ARM and like the, you know, the camera sub processor that had like a faster cache, and you're trying to place this algorithm to, you know, measure 6 degrees of freedom changes from the camera across all of these parts of the chip and like minimize latency and optimize speed. Those are like fun engineering problems you can kind of like go deep on forever. It's a nerd's night.
Yeah. So we had Kevin Bowers on a while ago, and one of the things he spent a good amount of time lamenting was that in the transition to cloud, there's been a focus on creating software abstractions that are designed to make it so it doesn't really matter what you're running your code on. It's just running on, you know, sort of abstract math in the cloud. Solana historically been hard to run in the cloud, both for business operational reasons about the way clouds charge, but also just like the hypervisors sometimes get in the way of some of the work that's trying to be done.
Yep.
I want to hear your sort of thoughts on like that as a design decision for Solana, but then also, you know, kind of going forward, do you see other classes of software where our reliance on abstractions are actually hurting our ability to make cool new things?
Cloud is pretty bad, but it's pretty good at like if there's strong business, like if there's strong product market fit for a specific kind of computation, you know, the engineers at those places will optimize and like kind of plow through the layers of abstraction to do the right thing. It just takes time, but you will see that I think with AGI, you will rapidly see like all the red tape abstraction, like stuff be blown away and have very, very optimized systems that are good at like the things that people want them to do. It's just hard to make it easy to program and high performance at the same time. Like it's just all the high performance benefits come from really understanding the physical limitations of the machine and then eking out, you know, performance everywhere you go.
How much of your work at embedded systems companies like Qualcomm was foundational in actually being able to come up with something like Solana? Obviously, there's a ton,
obviously, like, and the fact that most of the early team members were like the folks that I worked with for, you know, over a decade at Qualcomm. Like, it's just that knowledge of kind of having that instinct that this stuff, these particular optimizations and writing code this way will make it faster it's just become second nature after 10 years. So I think it was really, really important to have those folks and to have us kind of start like that. I almost like, this was like a weird metaphor that I had. It's that like, because, you know, we had this like 2 years, whatever, to build it, before we launched, my instinct was to like, this is kind of opposite of what of what people should do, but take as much technical risk as we could, that while still launching in 2 years, that would set us up for the fastest possible kind of design. And this is again kind of fighting that idea that if you have 8 hard engineering problems, there's a 50-50 chance you'll have a bug in each one. It's very, very unlikely that you'll be bug free. But there's kind of like if you come into that knowing that, like the opposite side of that is if you have 8 hard engineering problems and you just fix one at a time and the rest are slow, it actually becomes very, very hard to fix them one at a time. Like you get stuck with like legacy code and legacy dependencies and legacy APIs. What I really didn't want to happen is us getting stuck with some legacy thing that was just really hard to fix, like really hard to incrementally change. So what we got lucky with is that the implementation was actually pretty decent, only fell over under extreme load, not even due to design, but just due to bugs. And that we didn't build anything that was like excruciatingly slow that you cannot incrementally get around.
What were some of those risks you took?
Those are actually like the articles that we wrote on the 7 or 8 innovations of Solana.
Yeah.
And you're kind of dealing with the major hard problem is just propagating the data around the world. And Turbine was a pretty novel idea at the time. So we used erasure coding, and blocks are transmitted in chunks, not in one block at the same, not one block from peer to peer at a time, which is how Bitcoin does it, or Ethereum does it. And like I think most layer ones do it that way. So you basically propagate between peers, you send a block out, the entire block from peer 1 to like peer 2, 3, and 4, and then they fan it out through gossip, kind of in this random way. And it's very robust and very very fault tolerant, but it's very slow. So yeah, what we did was optimize block propagation, and it has to stand up with like adversarial nodes, and we did a whole bunch of testing. It also has to work on open internet, not just like in a kind of cloud optimized environment. We made some assumptions in the V0 that broke as soon as we tried to to run it on the open internet. So stuff like that. SVM itself like is a pretty big risk.
Yeah.
Like building a new virtual machine, or even though we reused a lot of existing technologies, we used Berkeley packet filter as the bytecode and LLVM as a tool chain. You still have to create this runtime environment that kind of glues all these things together. That was a lot of work and a lot of code.
So that's like a classic one where it's like, you don't really touch the VM unless you have to. Like, what were the reasons that convinced you guys to say, this is a big thing to do, but we got to do it?
Well, like if we didn't optimize the EVM, then all these other optimizations would just kind of disappear, would become very marginal. Like EVM speed would kind of dominate. The fact that it's single threaded would dominate. Similarly, like if there was a mempool, that would dominate the performance costs. So then if you do everything else, but you still keep like EVM and a mempool, you get maybe 20-30% faster. And then you just can't differentiate like that. So if basically, like I would say that this probably goes to consumer product design too. If you're solving a problem for the user, like figure out if it's a new novel problem, ship it as fast as you can, then users will overcome any friction. They won't care about performance or price. It means you've caught lightning in a bottle. But if you're not solving a new problem, and I don't think layer ones are like Solana, we weren't solving a new problem. Ethereum already existed, and there were a bunch of other alternatives. You have to pick like a specific thing that you really, really care about, and then kind of Hail Mary, throw everything at it to differentiate.
Yeah, I think that's a really good kind of analogy there. I mean, it took Solana being 1,000 times faster to get anyone to notice it.
Yeah,
and
exactly.
So if you think of it like, if it were twice as fast as EVM on Ethereum, would anyone really have noticed?
Yeah, I don't think anyone would care.
Kind of running the clock forwards now. You mentioned that there's a bunch of work that was done sort of since launch, but also since, that kind of spring of 2022 timeline. How much of that work was stuff that was sort of originally somewhere in the original docs that were like, oh, we got to get this eventually, and now is the time we got to it? And how much of that was really net new work that was determined by seeing the network actually operating in the wild?
I mean, there's stuff that was new, like adding new system calls for cryptographic operations. So we just didn't anticipate people need it, or if they don't need it, we're not going to add them, right, until somebody really, really wants it. A lot of the work has just been fixing bugs, and that includes like performance optimizations. You can think of them as bugs, like this code is too slow, or uses too much memory. That's a bug. Go fix it. So that kind of work is just work that is almost always going to continue, because hardware changes and those physical limitations change from each version of hardware. hopefully they all get better, but that's not even always the case. Sometimes they get worse. Like, you know, magnetic disk drives can write a lot more data than SSDs. So stuff like that you have to keep in mind and like keep adjusting your implementations. Things like local fee markets and QoS, that was a net new thing that needed to be built to address like a problem that was obvious only after the system was in production and under load that exceeded the expected load. Like we had to actually see it get stressed to a point of breaking to understand the problem, which is kind of obvious in retrospect now, but like you really just didn't anticipate it.
A lot of software over its lifespan, no matter how sort of targeted and small the project begins, like bloats as it gets bigger. I think consumers are used to this, developers are used to this. You add new features, new libraries, new et cetera. How do you balance the need to add new things to the Solana network, like local fee markets and stake-weighted QoS, while also keeping the network performant and fast over the long term?
The reason code gets added is because it's better than the previous code, right? Like every release is better than the previous one.
Yeah.
And what makes it better is it solves some problem for validators, reduces memory or bandwidth, or like makes the software more stable. For developers, it gives them an API or removes a previous limitation, like how much memory they can allocate, like, or being able to grow programs and stuff like that. These are all like kind of like requests that people ask, hey, can you fix this, increase this limitation or fix this bug? And this is why the releases are basically non-controversial. You have a change, between 114 and 116. The changes are, cosmetic, right? Like from a very like bird's eye view, you're like, does anybody understand or care if program allocations are now allowed to grow or not after this update, after this feature is enabled? It just increases the programmability or stability or performance of the network. So those are kind of effectively the things that push forward. Some of the stuff that is like more controversial, I think generally has to do around like economics and things like that on the network. Like I would say fees for writable accounts, stuff like that. There's a lot more discussion on like whether these things should go in or how they improve the developer experience or like impact validator economics. And people argue about that, and then eventually, like, if it doesn't get like pushback from from enough people, it goes through if people want it or not. Like it kind of like is the old school Linux, open source model. Like if this makes the software better, then it gets shipped. If it makes it worse, it doesn't.
Yeah, it's a pretty good heuristic for figuring out what to ship and what not.
But like ideally, you don't want to churn. There's just obvious stuff that you don't want to do, like change APIs or break backwards compatibility. These are no-nos, and there's a lot of tooling and stuff in place to make sure that never happens.
Yeah, but then there's also stuff like Token 2022, which is sort of the next generation of token program coming to the network.
Yeah, so that's not part of the network itself. These are programs that anybody could ship. They're applications effectively. And ideally, you move as much of the functionality that you're working like in the code to the application layer. So the applications can decide as much of the policies and kind of decide how things work. It's not always possible. There's just, that's kind of how I think of it from a design perspective. Like, if you're building an operating system, you would want it to be like as flexible to the developer and as robust that if you have a single OS running 5 applications, they work as well as if you had one application per operating system instance. It just doesn't matter to the developer how it's deployed and how it's configured. It's just kind of like maybe, that you may make those decisions, but from the software perspective, that it's equivalent. And that's very hard to do. It's the job of the OS to balance all the resources and make sure all that stuff works. You can never get it right. Like it'll never be perfect, but it can be within, 0.1%.
Yeah. It's interesting to think about that. So where is the level at which something belongs in, to use your term here, the OS versus belongs in the application layer on a blockchain network?
There's some things it's just very, like, may take a very long time to do it all in the application space. So for example, in theory, the runtime could be as fast as native code. It could be so optimized that the just-in-time compiler and all the code transformation it does actually takes the user-supplied programs and runs them at native speed. But that may not be the case. And that sandbox that runs user-supplied code has limitations on it that the native code doesn't. So if you have like a cryptographic operation, like you need for elliptical curve or zero knowledge or something like that, it's maybe really, really tough to do it in user space. And people actually do it. They implement it in user space. It becomes an expensive operation to call, but they can demonstrate, hey, this works. There's an application that needs it. And then you can take effectively that code and add a system call or something like that. That becomes enshrined in the runtime. So this is how I think of it, which is, I think if you read the Vitalik's article on enshrining versus not,
yeah,
he kind of goes into it from a very different perspective, more about the social layer's decentralization. Like, should they enshrine liquid staking solution into the protocol or not? My view is that a lot of these problems come from some bug in the programmability of the layer that has caused like this very uneven distribution of power in the network. And like, for example, with like liquid staking and stuff, there's a, Solana's proof of stake, Ethereum is proof of stake. There's a very big difference there. The way Solana's designed is that all the components of that staking, the validator account, their vote key, their withdrawal authority, the stake that's delegating to that thing, the withdrawal key on the stake, all these things are separate programmable keys that can be taken over by a program address or by a user key at any time. So these are data structures that were created to be maximally flexible. And because of that, we have many different stake pools. None of them are very dominant. Not only that, these stake pools overlap validators. So it's not like Ethereum where 132 ETH node is a single validator that can only go into one stake pool. So you have like these weird inefficiencies that are hard to get around as a software engine with code in Ethereum. I think that create these kind of like centralizing effects because they're not as programmable. I don't know if that's always the case, right? There's obviously like lots of factors there, but my feeling is that like, if you make it very flexible and very programmable, it's actually very hard for a piece of software to accrue power because it's kind of like very easy to compete with. There's no moat there. And if there is a moat for some reason, I think it's kind of typically, to me, indicates there's something that's hard to program in the underlying layer.
Yeah, it's interesting to look at it that way because that's a real example where a lack of enshrinement has created a positive effect for Solana. I think it's also possible to look at it on the user level and say a lot of people would prefer if Metaplex were enshrined and were not an independent entity. And it's not necessarily that they don't trust the Metaplex Foundation. It's just that they view this as something that is almost mission critical beyond the point of being owned by someone at this point. What do you think about those sort of arguments that like on the network level, 100%. Yeah. On the program level, Solana actually has potentially a little bit more program control than you see on Ethereum?
Yeah, this is, I think, I wouldn't call this the enshrined versus not enshrined. These are like public good versus commercial good kind of question.
Yeah.
And like when you have, like what was really cool about DeFi Summers, you had these companies like Compound, Aave, and stuff, they built commercial products, which was like the lending protocols, but they also built a bunch of public goods, which is the governance modules and things like that. So those public goods were given out for free to anyone to fork and use, even their competitors, right? Even though those are very powerful public goods, I would say that Compound's governance is more successful than Compound, even though Compound itself was very successful too. But like the governance was like a very successful contract. And this is kind of like a dilemma on Solana because of some of the inefficiencies in the programming model where you don't have interfaces. You kind of have programs that become very dominant due to their implementation. There's positives and negatives there. That once you have a dominant program, it's very tempting to try to commercialize it and like try to make sense. Is this like, does this thing a product market fit? Is there a business model there? And how that works out, I think, is really, it's hard to predict. I can't say that like all pieces of software on Solana that are these low-level components should be pure public goods, that there is no business model that works for them, because I don't think that's true. I think you actually can build business models into them that perpetually fund them. But we'll see. Either way, that inefficiency in the programming model, like lack of interfaces, that's being solved. Once it's solved, you'll see like a lot of these moats go away, and we'll see what happens. Maybe like the public good interface thing will win out in the end.
One of the main differences I would say on a program level, and I'm curious if you agree with this, is that Solana does not require users to redeploy contracts every time they want to interact with a contract. There's a lot of efficiencies that come from that, like the price of NFTs on Solana is astronomically lower in part due to the fact you don't have to deploy the contract code. But that does mean that most folks are very comfortable and accustomed to using other people's contracts. Do you see that as sort of the long-term, like, well, socially folks will figure it out?
I mean, that's like a huge benefit. Like you have a single implementation of the token program or the stake pool program or the NFTs that has many eyes on it, that people have audited to death and have like looked at like over and over, and solves a lot of different problems. And that code is not enshrined because it's user space code, but it is socially enshrined amongst the developers that they're not going to go build another NFT program or another token program unless there's like a very, very nuanced reason to do so. Like a very specific like problem that it solves. And like, that's great. Honestly, like, it's not a bad outcome if the dominant top programs are these like single implementation that are extremely robust, that everyone reuses, that have no bugs, and everyone, because they've been audited to death, code reviewed to death, it becomes that like, selling point for like correctness. That's a very, very good outcome for contracts and for network efficiency.
So you've been tweeting a bunch more about AI. Solana Labs launched an AI grants initiative program and has sort of this like ChatGPT reference implementation. I'm curious where you see AI going in blockchain, but also sort of around the trust component here, because I think you hear a lot of the time when folks are talking about AI is like, oh, well, you can't trust the code because it's written by a machine. But we trust code written by humans every day, and humans make tons of mistakes.
I think people will get around to trusting code written by a machine. I think that because AI can also be used to verify the code. Like you can have effectively a different context, verify the code for correctness, and you can kind of build these adversarial models where like you build something, some other AI instance tests it, third one verifies it. All that stuff will get there. Actually, I think AI is awesome for code generation. I think this is like an amazing toolkit that's going to make software much, much faster than before, like software development.
Yeah. I mean, I was spending a lot of time looking at how much it's aided physical design. Like there are part generative systems now that you just give it the design specs and it gives you 6 or 7 different versions of a part that looks very different than a human might ever design. Have you been playing around with like AI generated code at all? Does it look reminiscent of code you expect, or is it sort of like in this mechanical engineering parody where it's just completely different?
No, it actually looks like code you'd expect, and like it's kind of buggy. Like right now it generates kind of buggy code. We're very far from having like an AI equivalent like L3 engineer.
Yeah.
Like AI is really good at tasks right now. You can give it short tasks, unit test this function, right? That kind of thing. It's very bad at like something that you'd expect a new grad to solve in like 2 weeks. You just can't do that.
Yeah. Interesting.
The question is, can it make the new grad solve that in like a day? A problem that they would otherwise take him 2 weeks. And I think that's close. And that's a very, very big change, I think, in software development. So like I think software is going to get cheaper to write, like cheaper to produce, like across the world, which will have, I think, more dramatic effects. Software is going to eat more and more of the world, and crypto is trying to eat the finance and governance part of the world, which is very resistant to being eaten. This is where humans really feel strongly that this should not be eaten. I think out of all other aspects of life, but it's slowly happening. I just can't imagine 20 years from now that most of the functions that banks do is like fully automated on chain.
What are some applications for blockchain technology that are not obvious today that you're thinking might appear as use cases in the future?
I'm actually more focused on trying to do stuff that's obvious today. I think that's just like really, really, really important to try to get users to go do the things that already work at scale. And those are payments, very, very simple kind of thing. Let's send money to each other in a cheap and fast way without, like around the world. I think there's a lot of like subtle things that happen on the web, and it's kind of like became super apparent to me. Everyone is in crypto Twitter, just like me. I signed up for the rewards program, and it's like a very painful process to actually get through Stripe. Like you got to send a bunch of identification, give up all your addresses and names to get like $20-$30 a month, right, from Max and Rewards. And it's a pain in the butt to use, and your money's kind of sitting in Stripe, pain to withdraw it and like actually get to use it. At the same time, this developer built this like USDC gated email thing based on my tweet called SoulLinked, where I just post an email address and people send me email, and if it doesn't come with a $10 USDC tip, I don't answer it. So if you haven't heard of it, it's called soullinked.com, and I'm totally at soullinked.com. So if you wanna send me $10 in an email that you really, really need me to respond to, that's the way to do it.
I've been thinking of using it for you too.
Yeah. It takes 10 minutes to set up, like not even 10 minutes. It was like seconds, because you connect to a server, it detects your wallet, you just enter the email that you want and the email that you want it to forward to your normal email, and you're done. And everything is already set up, all the financial rails are there, and it's just such a better experience for anyone that generates user content. So the problem though is that because it's such a pain to deal with finance on the web, these platforms are able to aggregate power by like creating these rails for a large number of content creators. So this is how they get like their moats. They own the content. They own the creator's financial relationship between the creator and the user. They own that rail and they own that connection. And once they own it, the creator doesn't want to leave. It's a kick in their revenues, right?
Yeah.
They're not like working for themselves or working for Twitter or for TikTok or whatever. because all of the financialization happens through these platforms. That creates all of kind of this segregated, heavily like adverb web that sucks. Like, open a website without an ad block browser today. It's impossible to read.
I won't.
Like, it's just insane. I don't understand, like, who uses the web? Like, who is this targeting? Like, it can't be human, so I don't know.
Yeah, that's kind of interesting when you think about it that way. Do you think advertising will eventually come for Web3?
I mean, Brave is trying to do it. I don't know. It's hard. It's hard to see right now, but like that's because crypto Web3 users are like the early adopters, weirdo tech people that already use AdBlock and stuff like that.
Yeah. All right. Last questions here. What do you think, what would you like to see more of in the Solana community, and what would you like to see less of?
I think less. We're actually doing pretty good. We don't have a ton of infra projects. We could actually use some more of people trying to build, like, I think, but you kind of see it as soon as I, post something, there's like a team that's picking it up already. They tell me, hey, we're working on
like Rome.
Like the shit. Yeah, like Rome, sequencers, that kind of stuff. I think it's worth, Solana should have one or two of those, but not be too overly focused on infra. I think what's important is the hard problem, which is like find a problem that consumers have that is so important to solve that they're willing to overcome the friction to use crypto. Like if you find those problems, you caught lightning in a bottle. Do more of that on Solana.
Nice. Well, Toly, thanks for joining us on the No Sharding podcast.
For sure. Glad to be here.